All right, pre-calculus students, I hope you are well. Today's lesson is writing equations for the sine and cosine functions. Our last video was a little bit on graphing. Now we're kind of going in reverse. Given some information about the graph, or given the graph, I want to write an equation for the sine and the cosine function. And once again, like the last video, we're only going to pay attention to the amplitude and the period for now. We'll get into midline, which we'll talk a little bit about midline, but midline, phase shift coming later. Okay, so these are your standard equations for sine and cosine. Remember, different textbooks use different things. Delta Math swaps C and D. I still haven't figured that out. That's really strange, but maybe it's only in a few of the problem types. Okay, so just to be clear, we are only focusing on A and B today. Okay, C is going to have something to do with shifting the graph left and right, which is called a phase shift with trigonometric functions in trigonometry. D is going to affect the midline, which will come later. So we're only focusing on A, which gives us amplitude, and B, which has something to do with the period. Same thing with cosine. So y equals A cosine of B x. Understood the argument. So generally you put the argument, meaning the input of the function, in parentheses, but not always. So if it's 2x, you'll just see 2x. But if it's 2x plus 5, you'll see parentheses. So you can get in the habit of always using parentheses. But if there is no value being added or subtracted, generally you won't see parentheses. All right, so let's dive into our first example. All right, so only 4 examples. So this should be a short video. I'm scared to say that. We'll see how it turns out. So we're going to write the equation for a sine function. Remember, all I need is to find A and to find B. So I'm going to write a sine function. So when I'm done with this problem, I will have an equation that looks like this. So I need to find A and I need to find B. So the amplitude is given to be 3. So the amplitude is given to be 3. Okay? So this is where it gets a little tricky. If the amplitude, the absolute value of a number equals 3, so it's been a while since maybe you've done absolute value. So what can A be? A can either be 3 or A can be negative 3. It doesn't matter what number I put into the equation, whether I put in 3 or negative 3, the amplitude will be 3. So we really have 2 possible answers. Negative 3 sine of bx, I still need to find b, or y equals 3 sine of bx. Either one of those are fine. Okay, so if the amplitude is 3, then a could be 3 or negative 3. Now, in general, most students would just make it 3, but it could be negative 3. Okay, so now the question is, how do I find b? Well, let me just remind you real quick. The formula for period is 2 pi over b. So the period is always 2 pi over b, which was given to be 6 pi. So the period, 2 pi over b, equals 6 pi. Okay, now if we were in the classroom, I would make a little sideboard. So I'm gonna come over here, and this is my sideboard. Pretend we're in class. All right, you know that 10 over 2 is 5. All right, I hope you know that. You know that. 10 divided by 2, definitely 5. Well, numerically, if I have a fraction, I can actually swap the denominator for the whatever value is on the right-hand side of the equation, meaning I can take these 2 numbers and switch. I can make this 10 over 5 and 2, and the equality is still maintained. So 10 divided by 5 is 2. Okay, so this is a trick. Anytime I'm trying to solve an equation, and there's a fraction, and the variable I'm trying to solve for is in the denominator, I can literally just switch those 2 numbers. Okay? So it's just a shortcut. It's a numerical trick that you're thinking, I don't need to know that. Yeah, you do. You will be taking the SAT, and you guys know, if you haven't already taken the pre-SAT or the SAT, it's timed, and you've got to move quickly. So all of the little tricks and shortcuts you can learn and understand you'll do better on the SAT. So I'm going to swap the B and the value for the period every single time I'm trying to find the period. Okay, and there'll be other formulas where this is the case. So I swap. So that becomes B in 6 pi swap position. So I found B. Now I just need to simplify. So every time you swap, you just need to make sure you reduce carefully. My pi's divide out, and 2 over 6, of course, is 1/3. So B is 1/3. So now, to build my final answer, y equals 3 sine of 1/3 x. There are a lot of circles and things. Answer. Okay, that's it. You were given the amplitude, that's A. You set the period, 2 pi over B, right? Set the period equal to 2 pi over B. Solve for B. Boom. Build your equation. So in every one of these problems, A is the amplitude. That's pretty direct. The period, right? You'll use the period to find B. Build your equation. Example 10, done. Example 11, very similar. Still want to build a sine function, but this could be a cosine function too. So just if I ask you to build a cosine function, you use COS. If I ask you to build a sine function, you use SIN, all the same. So y equals A, amplitude, times sine of BX. I already know my amplitude is 2. So I already have 2. So I need to set 2 pi over B equal to the period. Swap. Ooh. Battery might be getting low. And then reduce. 2 pi over 4 is pi over 2. That's my value of B. So I build my equation, pi over 2x. Final answer. And once again, you really could put plus or minus there, because if the amplitude is 2, A could be 2 or negative 2. Either way, the absolute value would be 2. All right, so if you're given the amplitude and given the period, you can build an equation for the trig function sine or cosine. So now we get to the more interesting problems. Okay, once again, all of this will be, you'll do some practice in delta math. All right, so amplitude. So I have 2 slides here. I'm going to go back and forth. So I'm going to start with amplitude. The battery's getting low. So amplitude. The amplitude can be thought of different ways. So if you, on any sine or cosine curve, before I even go there, let me be clear. This curve will touch the y-axis one time. Okay, so if you look at example 12, because it touches, not at the origin, because it touches on the y-axis somewhere other than the origin, this is going to help me know that I need to use cosine. Is going to be a little bit easier, because the original cosine function does not go through the origin. It goes through some point on the y-axis other than the origin. Where if you look at 13, and I'm jumping ahead intentionally, 13 goes through the origin. It's going to be much easier to use the sine wave function. Okay? So I just want to make that clear. If I say build an equation, sine or cosine, I'm not going to tell you which. If it goes through the origin, sine is easy. If it doesn't go through the origin, like number 12, use cosine. Okay, so we want to build an equation. So we want to build an equation that's going to be of this form. So I need to find the amplitude first. Okay, so the amplitude is always going to be, now I'm going to show you 2 different ways. The amplitude is, according to the notes from the last video, there is a formulaic way of doing it, which in my opinion, so this is method 1, so it's a little complicated. To me, this makes it harder than it needs to be, but some students are like, just give me a formula, so I'm going to give you a formula. Bow. So the max value is 3. The highest point on the curve has a y value of 3. The lowest point on the curve, the minimum value is negative 3. So you can always find the amplitude given a graph by taking the max value minus the minimum value. Now you see why I don't like this. You know I'm going to make a mistake with arithmetic. Yeah, you've seen me in class. So 3 minus negative 3 is 6. So what you've basically said is the distance from the lowest point to the highest point is 6, but that's not the amplitude. The amplitude's half that. So that's 6 divided by 2, which is 3. So that's method 1. Method 2, which I prefer, is find the midline. Find the line that cuts the wave in half. Meaning find the line that gives you a piece on the bottom that is the same length or height as the length on top. Okay? And finding the midline is generally pretty easy. It's going to be halfway between the max and the min. So in this case, the midline is the x-axis. So the amplitude is literally the distance from the midline to the maximum value, or the midline to a minimum value. So there, the 3 is my amplitude. Okay? Now, is a 3 or negative 3? Remember, the original cosine function starts up on the y-axis, up, and goes down and up. So this implies that a is going to be a positive value. If the curve started, let me use a different color. If the curve started down here and went up and then down, that would imply that a is going to be a negative value. Okay, so that's something a little later. We'll spend more time with that. So far we have y equals 3 cosine of, I don't know, x. Okay, so to find the amplitude, max minus min divided by 2, or midline to max, measure it, look at the spaces, 3 spaces high. Okay, that's going to get a little bit more complicated as we shift these graphs up and down as there's a d value. Okay, so that is amplitude. Amplitude's pretty easy. So let's talk about the period. The period. So to discuss period of the function. The period of the function, several ways of doing it. You either need to go max to max, okay, which in this case, because the maximum value really starts at an x value of 0, that's going to be the easiest way because it's a cosine function, max to max. Or you can go minimum to minimum. There's some times when on the number line, that's easier. Okay, the third way is, which is easier for sine, first, right, start somewhere on the x-axis, pass the next x value, and go to the next x-intercept. So x-intercept, skip one, x-intercept. So if you look, that is one full wave. Remember, that's what the period is, one full cycle. Okay, but in this problem, I'm going to go max because the max starts at an x value of 0. So I'm going to go from here to there, which is easy to measure. 0 to 1, so the period is 1. All right, so right now we have y equals 3 cosine of b x. I need to find b. So remember, 2 pi over b, the period is 1 graphically. From peak to peak, from max to max, that's your period. Swap the b and the 1. 2 pi over 1 is 2 pi. Final answer. Okay? Let's try another one. Bloop. Example 3. I'm going to use the easy method. Now, we've got to be careful here because if this y value is 3, that means 1, 2, 3. I want to build a sine function because it's going through the origin. So I'm going to build a sine function. The height is 2, so I have y equals, now here's where I need to be careful. The original sine wave function went up, down, went up, and then down, and then back up. But this one is down and then up, which means it's been reflected, which means A is negative, which means not 2, but boop. Think of it as it went down first 2 spaces. That's going to be a -2. Okay, so -2 sine of, now I need to find B. So to find B, because it's a sine function, I like to think of it as not peak to peak. You can go peak to peak, but for sine it's easier if you go, ooh, hey, there's my music, guys. Don't be scared. My kids hate my music. One day. All right, let's try that again. All right, so because it's a sine function, I like to measure the period from the x-axis to the, what I call next, right? Skip the next x-intercept and go to the third x-intercept. So 1, 2, 3, that's one full wave. This x value is 5, so that means we have 1, 2, 3, 4, 5. So the distance from here on the at the origin to one full wave is 4, which means the period is 4. So I know 2 pi over b equals 4. So the period is 4. Swap the b and the 4. 2 pi over 4 equals b. Reduce pi over 2. Plug it into your equation, and you are done. So the equation is -2 sine of pi over 2x, negative because the function went down and then up. So remember, sine generally goes up and then down for a positive a value, down and then up for a negative a value. All right, super quick recap. The goal of this video is to show you how to, if you're given a graph, build an equation in terms of knowing the amplitude and knowing b, which you find b by knowing the period, or if you're given the amplitude directly and the period directly, you can build an equation. All right, guys. Whew, under 18 minutes, not bad. Study those examples and then get into the practice and be ready to present in class. Always be ready to present just in case somebody's having technical difficulties or someone hides and pretends. Maybe if I'm quiet, he won't make me present. Okay, be safe, guys.